What's up everyone and welcome back to my channel. During my studies at University of Padova, I had a particular course called Software Platforms, and as a final project I had to build a microservice application on Java, and the title was The Guardian Newspaper Topic Modeling. During this video we will see what are the requirements, how I implemented it, the design, the architecture, and how I will be deploying it using Docker Compose. So stick with me while we dive deep into this project. So let's see the project. Introduction. Now, this project consists of implementing a microservice architecture to fulfill the following requirements. The first one being monitoring articles from online newspaper. We specified that we're going to use the Guardians. That is because it is free and you can use with its you can play with its API. Now, the second one is storing articles in a database for fast retrieval. And the third one is making articles searchable, so you need the search engine for that. And the last one is extract representation of themes using topic modeling libraries. A little bit more on the description. The user will need an entry point. In this entry point, he will need to insert a keyword and a label for the query. A start date and the end date based on the period that this news was published. After the first query, and the system will do all the steps behind, he can do another query, which is taking a representation of themes for that particular word that he will insert. So the first one is query, number of topics, and number of word per topic. Now, in case you have no idea what representation of themes are, let me explain. It is a machine learning algorithm behind that, based on a keyword and a data stream that it has behind, it will respond to you with some other keywords that are related to the first query. So in case you search about Coca-Cola, it will respond to you with black color, sugar, bottle, and a lot more keywords related to Coca-Cola. So that is a representation of themes, and that is the last step that we will see. So yeah, this is the description, and we needed to implement this. We needed a microservice architecture with a database and a search engine. It was a requirement that the programming languages that we write was on Java. And yeah, we can select whatever we want, whatever service, however we desire. So this is how I implemented it, the overall architecture. So we have the user, and the user will be communicating over to the front end, which is a simple HTML, JavaScript, and CSS website. And this front end plays the role of the mediator, meaning that it will keep track of what is going on the system and will communicate with other microservices on the background to do what is supposed to do. Now, the first one being the data collector. Now, this data collector, as I said, everything is written in Java. The data collector, what it does is that it gets all the data based on the query that the user inserted on front end. Front end sends those data to the data collector, and data collector sends some query on the Guardians API using a Guardians API key for authentication. And after it gets all the data, it will put them on a MongoDB. Now, the second requirement was to have a database to store all the newses. In order to make that fast, so we do not need to go all the time to the Guardian API, we save it on a MongoDB. MongoDB is a NoSQL database, and you can save documents in it, JSON files, whatever files you want. And yeah, that is what our data is about. So it is a document, and we are inserting on the MongoDB. And data collector does just like that. And after it finished, it sends a response back to the front end. And the front end keeps tracks that the data are collected. Now, the second microservice is index creator. After the front end has triggered it, it pulls all the data from the MongoDB and it creates an index on the Elasticsearch. Now, the third requirement was to have an or a search engine. So you need to implement the search engine in order to retrieve the data fast. Because if we did on a MongoDB, it would be quite slow. But on an Elasticsearch, it is very, very fast. That is why the index creator creates the index and then it sends back to the front end a response that the index is created. After the front end responds to the user that the data is collected and indexed, then the user needs to do the second query, meaning that he can write a word that for all the data that are collected, topics that he wants, and words per topics. So the front end sends this query to the topic modeling mallet. Now, in Java, my professor provided us with this machine learning algorithm, which is called mallet. And all I did was change the data stream. From a file, I changed it to take it from on Elasticsearch. So that is what this microservice does. It takes all the articles from the Elasticsearch with that particular word, and based on all those information, based on all those news, it responds to the front end with the topics. So it does all the computation and it responds it to the front end back. And the front end provides a visual representation of all those themes on a tabular view to the user. So that is the overall architecture, and all it is using REST API. All of them are microservices. In case you're doing it, you can do whatever you want. If you want to replicate it, replicate so. So let's get going on the code and how are we going to deploy it. Now, what we have in here. Everything is going to be deployed using Docker Compose. Now, since it is very fast and it helps me with the development, in the future we will see how we can deploy it on Kubernetes also. But for the moment, Docker Compose. And what do we have? It is one front end, one data collector, one index creator, one topic modeling mallet, one MongoDB, one Elasticsearch. And also we are going to create a Mongo Express just for displaying all of our data on Mongo. So this is the Docker Compose. And first of all, let's run it. So while it runs, we can see what the code is about. So Docker Compose up -d as a detached. And yeah, everything started running. Because it is already, all the images are created. Now, services, it is Mongo. It is using the image Mongo, the username, password, and also a volume just to create a basic sample for an database, or a table, you can call it on MongoDB, but you can see it right here that all it does is create this collection. Mongo Express, this is the image which connects with the MongoDB, and it provides you with an overview of what is going on the database itself. Elasticsearch, using this image, it is a single node. We have the username and password in here, and the ports that are exposed. Now, we have the collector. Collector, it is on building all the image itself while we run Docker Compose, and it is building the image from this Docker file. Basically, it is on collector folder, Docker file right here. It is exposing port 1990, which correspond to the 8080 on the container itself. Yeah, we are inserting some environment variables, which is the Guardian API key, the Guardian API URL, and the MongoDB URI, meaning the connection string for the MongoDB. We have the indexer. The indexer is also building from this path Docker file, exposing 1991 on port 8080 of the container. We have inserted some connection string for the MongoDB, and since indexer needs to connect with the MongoDB and also Elasticsearch, we have provided also the Elasticsearch URI, username and password. The topic modeling. All this topic modeling container is going to be connected with Elasticsearch service, and it is using this Docker file. So basically it is on the topic modeling folder inside, and it is on port 1992. The front end, which is a simple HTML, CSS and JavaScript file, it is using this file as the building image, exposing port 8080 and API URL of 3 microservices that we have. Now, before going to the front end, let's see our databases, so the MongoDB and also the Elasticsearch. Mongo Express provides you with a graphical user interface and connects with the MongoDB, and we can see that there is no data whatsoever in the entire database server. And also in here there is one index that it is pre-created from the scripts, and there is no documents. So let's go to localhost port 8080 of our front end, and let's see, we can see that we can insert two queries. So the first one being for collecting the data and indexing it after, and the second one being for providing and getting topics. So let's start with a label. So elections, for example, because USA had recently their elections and Donald Trump won. So let's go from 1 January to 21. And let's say Trump, right? Let's do collect some data, indexing it, and the data is pulled and indexed. Now, if we go back to Mongo Express, we can go to news. We can see that a collection is created called news. This collection has all the news taken from the Guardian's newspaper, and we can see that it has 200 documents. Now, on the Elasticsearch, we can see also that it changed to 200 document count. And if we search it, we can see all the text that those newses have inside of them. After this, the topic modeling machine learning algorithm, basically it's going to take all this data and provide you with topics. So let's see the second query. So query text, and we can go with Trump. Numbers of topic, we can go with 10, and numbers per topic, we can go with 10. So we submit, and our microservice basically provides you with this kind of representation of themes. Now, what do we have here? Through your Trump, York Power, white leaders, foreign decision officials, threats involved. So those are all keywords related to Trump. Can be great, it can be bad. Who cares? We are for IT right now. So our front end and the entire application works. We have all our data on MongoDB and also Elasticsearch. And so let's see a little bit on how those applications are and how I have built them using Docker files, which gets created a Docker image and then deployed with Docker Compose. So let's see the hosting part. So back to Visual Code. Let's start with our front end. So Dockerfile, it is using Nginx as its root image, removing the default folder, copying our front end folder in here with our static files, exposing port 80, entry point, copying it and running it. And now on the entry point, all it does is that on this config.javascript, which is right here, basically it just changes the data of our collector, indexer, and topic modeling URLs. So that is all it does, and it starts Nginx, and it starts exposing our website. If you did not see my latest video about building a website and hosting it, well, there I used Apache. In here I've used Nginx. I will link to the description in case you want to see how to host a website using Apache. The front end gets built, and the image then it is going to run. After front end, we have collector. The collector, we have the Docker file. Now, all JavaScript images are built using multi-processes, or you may call whatever you want, but basically it uses two images. One image, it is for building and compiling the code itself, and the second image, it is for hosting it. So our Maven image right here, it is as build. It copies our pom.xml, and it installs all the dependencies. After that, it installs all the Java config files, and it packages it. Now, this package gets copied to this Eclipse Tamarin. Basically, you can specify whatever Java version you want based on what you're working with. And from build, it copies all the jar file, and it copies as app.jar. And After that, it runs java -jar and specifies the file of the jar. So the collector. Now, basically the collector and also the indexer, they have the same Docker file. Even the topic modeling, because all of them are on Java, they have the same Docker file. No need to explain that further. So let's see a little bit of the code. Now I can go back to our documentation in here. Now the data collector, basically it gets our parameters, which are label, start date, end date, and keyword, and it uses the service fetch articles. These fetch articles, basically what it does, it is a service in the background that connects with the Guardian API URI, and it collects based using this API token that I've taken from their platform. All those articles are saved as a list, and all this list of news are saved then to MongoDB. News service, which connects with the MongoDB database and saves all the news there. After that, it responds to the front end with a status response as okay. So the index creator, what index creator does, it is basically connecting with MongoDB and then with Elasticsearch and putting all those data. So on /API/index, it is exposing. It requires only the label parameter, which frontend provides with it, and find out by label. Basically, it takes the label and it collects all the data from the MongoDB on this particular label for the document. After collecting all the data, we transform it. So we remove the label from the document itself because that is saved. And the reason is that the topic modeling mallet did not want this label. Otherwise it did not work. I did not know how to fix it. That is why I removed it and I let as my professor provided it. So all I did, it was command this get label, so the label would not be provided to the news Elastic News model. And all those newses are then saved to Elasticsearch. So they are creating into the index and responding back to the HTML, to the website, to the front end with a response okay. And the third one is topic modeling mallet. Now, what it does, it is exposing path API analyze. It requests parameter of query text, number of topics, number of top words per topics. So I specified 10 and 10 on my example. And with this query, it performs analysis. Now, what is this analysis? I have no idea, in fact. It is using mallet. It is provided by my professor. And all I did in this service was change it from a file source to Elasticsearch data stream. That is all. And after that, I have no idea what it does in the background. But at the end, it provides you with a JSON file and it provides you with all the topics and the number of words per topics. So all the words. And after that, if the response is okay, it will represent at your front end. So those are all the microservices that I build. All of them are in Java. All of them are packed as a Docker image, and this Docker image then it is deployed as a Docker container using Docker compose command. So as you saw, all that the deployment process was just one command, and the Docker compose knew how to do everything. The motivation for the specific design choices. Well, since we were required to do the microservice architecture, we provided an architecture that has elasticity, scalability, availability, fault tolerance, but as a trade-off, it was very hard to test, complex to develop and to deploy compared to a monolith application. So you can do everything that I did as a monolith application, providing the HTML page and all the microservices together. And but that was a requirement, so that is why we did as a microservice architecture. Now, another motivation, it is that instead of using REST API, so in the future, in case you want to make this application large, you can use event-driven architecture. Why is that? Because as I said, everything worked with REST API, but in case you have a lot of customers, well, those REST API, in case one of the service is blocked or it is doing a lot of computation, so the collector, maybe it is reading a lot of news between a very large period of time, well, those REST API will not work. That is the reason why you can use event-driven architecture. So all the messages, so you can use a RabbitMQ maybe or SQS from AWS, and using messages and processes, the front end working as a mediator, or maybe you can have another service as a mediator. Well, you will save all the messages and have every request from the start to finish. Now, still, this is not the way to do it. Why? Because on the last part, the last query that we did, well, the user does a query and it needs a response. And this does not really work well with messages. So for that, it probably need the REST API. And since you're incorporating REST API and also another architecture that has messages, well, you can choose a hybrid-driven architecture. That is the best possible way to make this application. Now, you can choose whatever you want. It has trade-offs, and also the hybrid-driven architecture has trade-offs, but just experiment it. Have your hands dirty and play with services, microservices, containers, do some programming in Java or Python. So it is very fun to work with those kind of projects. Yeah, the deployment consideration, we made everything possible with Docker Compose. And yeah, that was all for this project. So a little bit of recap, what we did in this video. We had a requirement to build a microservice architecture application that we accomplished. The title was The Guardian Newspaper Microservice Architecture for Representation of Themes. So basically we had one front end on HTML, JavaScript, 3 microservices. One was for collecting data from the Guardian's API and saving it to MongoDB, one for collecting the data from MongoDB and saving it to Elasticsearch for it to be very fast. And the last one was for representation of themes, taking all the data from Elasticsearch engine and providing to the user as topics. We worked with MongoDB, we worked with Elasticsearch, and we deployed everything using Docker Compose. Now, in case you missed my latest video, it is this one right here. It is for building a website and a web server, what is a web application, web proxy, load balancers, and even securing your application with HTTPS. So yeah, like and subscribe and have a nice day. Bye.